Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the videos, and then once everyone is finished, you can unpause the video and I'll go over the correct answer. So for the factoring, you're going to have x minus a number and x plus a number. And the reason we know one is minus and one is plus, this is a negative. So what two numbers are going to multiply to give us 24 and subtract to give us a negative 5? 8 and 3 multiply to give you 24, and the negative 8 plus 3 is negative 5. So that'll be your factoring answer. For the math knowledge question, the ACT loves these Roman numeral 1, 2, and 3 questions because it's a multi-part question. You have to know which of these and then make sure to match it up correctly down here. So it says 4 distinct lines line a plane. So we've got our plane here, and we've got 4 lines, and only 2 of them, it says exactly 2 of them, are parallel. So those 2 are parallel. That means they will never intersect. And it says, which of the following could be the number of points where at least 2 of the lines intersect? Well, if we have it where one line is here and one line is here, that would be 1, 2, 3, 4, 5 intersection points. So that means that number 3 works. So it's not 1 only. It's not 1 and 2 only. So that eliminates 2 of the answer choices. We're down to, if we guess, we get a 33% chance of getting it right. If we draw another plane, and we again have our 2 lines that are parallel, we could have one line here and one line here. And so they could intersect at this 1 point, 2 points, and 3 points. So 3 points would work. So that means that 1 and 3 have to work. So it's not 3 only. And then it's either 2 does or does not work. So this one is basically the same as this. I draw my lines, and then I draw the other 2, and they intersect somewhere. The 2 red lines, if you move them, they're right here. That's where 3 is, and if you move them further, that's where 5 would be. So those are basically the same thing. The only way you would get 4 is if you had these 2 that are parallel and these 2 that are parallel. That would give you the 4, and it says only 2 of our lines are parallel. So that means that 2, the 4 option cannot work. So that means that our answer has to be D. So hopefully that helps you with that one. So we're looking at lesson 5 today. We're going to look at more theorems about lines and planes. So hopefully after this lesson you will understand and be able to use postulates and theorems about points, lines, and planes and apply them to some problems. So we're going to look at a little bit more with definitions. Perpendicular lines, those are lines that intersect at 90-degree angles. So if we have a line here and then a line here, these are perpendicular, and most of the time they'll put a little right angle there to show that they are perpendicular. The symbol for perpendicular looks like this. It's basically an upside down T. So whenever you are writing in math, if you would rather use this symbol for perpendicular instead of writing out perpendicular, that is completely fine with me. I actually would prefer it because that means it takes you less time to write perpendicular. You don't have to, but that is completely okay to use that shorthand. Parallel lines means that they do not intersect. We just talked about parallel lines, so there are parallel lines. One example would be your railroad track. Those 2 are never going to cross. They're never going to touch each other. They have to be parallel. The symbol for parallel, the book does it straight up and down like that. But I find whenever I write A parallel to B, sometimes it starts looking like 2 L's right next to each other. And so what I do is usually slant them just a little bit so that it doesn't look like 2 L's. Some books slant them, some do them completely vertical. Either one of those is fine with me. It doesn't really matter as long as they look parallel. Okay, now we're going to look at parallel planes. Those are planes that do not intersect. So looking around the classroom, the ceiling and the floor are parallel planes. They never cross. The wall in front of you and the wall behind you are parallel because they never cross. Your desk is a flat surface, and the floor, that is a flat surface. Those are both planes that are parallel. There are lots of parallel planes. Maybe y'all can think of some other ones. Skew lines are lines that are not coplanar. So if you have a three-dimensional figure, and we're going to take the bottom here, we're going to look at that plane right there. If I draw a line on that plane, so I'm going to do this one right here, and then I come up with a line that is not on this plane. Let's say I put it here. Those are not on the same plane. However, could I put a plane that would cover both of those two red lines? I could. It would be the front of this box here. Okay, so those two are not examples of skew lines. However, if I put a line here on this edge, is there a way to put this line and this line on the same plane? No, they will never be on the same plane. And so that would be an example of skew lines. If y'all want to look at a tissue box, it's the same concept. Pick one on one plane, and then pick one. This would be a skew line. Another one would be here. And now if I kept this one going, it would look like they intersected right here, but that's only because it's a two-dimensional picture of a three-dimensional object. And so they do cross, but they don't actually intersect if you look at it as a three-dimensional object. All right, so theorem 5.1. If two parallel planes are cut by a third plane, then the lines of intersection are parallel. So looking here, in the figure, planes J and K are parallel. Name two pairs of parallel lines. So the planes J and K are the ones that are horizontal. The lines that we know have to be parallel are going to be on one plane. So one plane that intersects J and K is this one right here. What is the intersection of plane J with the one that I have outlined in red? XY. And then what is the intersection of K with that same plane? Line AB. So those two have to be parallel because we know these two planes are parallel, and then this plane intersects them both. So these two lines have to be parallel. I'm going to do one in green. Over here, this plane also intersects J and K. And so it would be LM and line RS. Those two would also be parallel to each other. Notice that we're not picking one from the red plane and one from the green plane. You have to stay on the same plane that intersects the two parallel planes. Theorem 5.2 says that if two lines in a plane are perpendicular to the same line, then they are parallel to each other. So if I draw two lines that are perpendicular to the same line, that means that this line and this one have to be parallel to each other. That's all that's saying. In a plane, if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other. So we have two parallel lines, and if a line is perpendicular to one, then it also is going to have to be perpendicular to the other. So that's how that works. Looking at the next theorem, if two lines are perpendicular, then they are going to form congruent adjacent angles. If you have perpendicular lines, that means that this is a 90-degree angle, and actually all four of them are 90-degree angle. And so those are congruent, and adjacent means they're right next to each other, and these are, so they form congruent adjacent angles. Looking at another theorem, if two lines form congruent adjacent angles, then they are perpendicular. So that's very closely related to the previous theorem. Looking at another one, all right angles are congruent. All right angles are 90 degrees, and 90 degrees is always congruent to 90 degrees. Like I said a couple of lessons back, sometimes the theorems and postulates may be things that you already feel like you know. They are just putting them in mathematical terms, basically. All right, so let's look at this example. In the figure, line AB is parallel to DC. So the way that I can note that on my figure is to put a little arrow here on line AB and do the same thing on line DC. And so if you ever see those little arrows, that means that the two lines are parallel. And then it tells us that KL is perpendicular to DC and PQ is perpendicular to DC. What is the relationship between KL and AB? Well, these two are parallel, so that means that this is also going to be a right angle. So line KL has to be perpendicular to line AB. And then it asks, what is the relationship between KL and PQ? Well, they are both perpendicular to this line DC. So that means that KL has to be parallel to line PQ. Okay. Now it asks for the measure of angle 1 and the measure of angle 2. If you look here, angle 3, this is a right angle, so that means that 3 is equal to 90 degrees. So angle 1 is also going to be equal to 90 degrees, and angle 2 is going to be equal to 90 degrees, because all four of these angles are going to be 90 degrees. All right, looking at postulate 10, it's called the parallel postulate, and it says through a point not on a line, there exists exactly one line through the point that is parallel to the line. So we have a point that is not on a line. And it says that there is exactly one line that's going to go through this point that is parallel to this line. So this is a parallel line to the first line. And so if I move it around, it's still going to be parallel. And then it's only going to go through that point one time. And so there's only one line that's going to go through the point that is going to be parallel to the given line. That's all that postulate is saying. So we have a line DE. And we have a point K that is not on line DE. And it says draw as many lines as possible that are parallel to DE that go through point K. So how many lines can we draw? Only one. And that's from the parallel postulate that we just looked at. Okay, so looking at theorem 5.7, this one has a name. It's called the transitive property of parallel lines. So if two lines are parallel to the same line, then they are parallel to one another. Let me say this. If Jasper is the same height as Daniel, and Daniel is the same height as Jason, then that means that Jasper has to be the same height as Jason. That's using transitive property of heights, I guess you could say. It's the same concept with parallel lines. If this line and this line are parallel, and this middle line and this last line are parallel, then this first one has to also be parallel to the last one. So that's basically all that theorem says. So let's look here. Marty wants to hang streamers in front of a doorway for a party. He wants each of his streamers to be parallel to the first one, which is already hung up, and it's equally spaced. He measures the distance between the first and second streamer and verifies that they are parallel, but his ruler is not long enough to measure the distance between the third streamer and the first. How can Marty ensure his streamers are parallel? So he hangs up a streamer and he hangs up another one, and they're parallel. And he measured this to make sure that they are parallel. But he can't get all the way to the third one to make sure that it's parallel. So how can he make sure that his streamers continue to stay parallel? Using the theorem that we just looked at, the transitive property of parallel lines, if he makes the streamer parallel to the one right next to it, then it's always going to be parallel to the first as well. And so that's how he can do it. Just make sure that the two right next to each other are parallel, and as he goes, as long as those are parallel, it's going to continue to stay parallel with all the other ones as well. Okay, so now we're going to do some practice problems. So y'all pause the video and try these, and then unpause the video, and I'll go over the correct answers. In the first one, it says that the horizontal planes are parallel. Identify the lines that are parallel. So this is one plane that intersects the two parallel planes, and the lines where they intersect are line AB and line CD. So that would be lines that are parallel. And then this is the other plane that intersects those two parallel planes. And so line EF and line CD are parallel. You could switch this to make it BA and DC, but these two lines are parallel and these two lines are parallel. There are no other answers that would be accepted for this example. So if you put AB is parallel to EF, that is wrong. We don't know that they are parallel. They could be, but we don't know that for sure. We only know that AB is parallel to CD and EF is parallel to CD. Okay, looking at B. In this figure, they tell us CD is parallel to GH and CD is perpendicular to AB. What is the relationship between AB and GH? Well, if these are parallel and this is a right angle, that means that there are right angles here and here. So the relationship between them, they are perpendicular. So you could write AB as perpendicular to GH, or you can just say they are perpendicular, whichever one. Okay, let's look at C and D. Y'all try them, and then after y'all are finished, unpause the video and I'll go over them. It tells us that RS and XY are perpendicular, and there's a right angle here to help show that, and VW and XY are perpendicular, which it shows that as well. What is the relationship between RS and VW? That's down here. How are these two lines related? They have to be parallel because they're both perpendicular to XY. Okay? Looking at this next one. What is the relationship among the angles at the intersection of RSTU and VW with XY? So how are these angles all related? They are all 90 degrees. And why are they all 90 degrees? Because the lines are all perpendicular. So they have to be congruent 90-degree angles. Okay? Let's try these two practice problems by yourself, and then y'all unpause the video and I'll go over them. If line X, Y goes through point M, and XY and CD are parallel, how do we know that JK is not parallel to CD? If you look at the picture, obviously it's not parallel, but what postulate or theorem helps us know that it's not parallel? Based on the parallel postulate, which tells you that only one line through a point not on the line that is parallel to the given line can go through the given point. So since XY is parallel to CD and XY goes through M, any other line that goes through point M is not going to be parallel to CD. Okay, looking at F. Carlotta is assembling the floorboards for her deck. How can she be sure that all the boards are parallel to one another? So all she has to do is make sure that if this board is parallel to this one, then this board needs to be parallel to the second one. And then this board would be parallel to that one. Just make sure that all of your adjacent boards are parallel to each other. Then all the boards will be parallel to one another by the transitive property of parallel lines. So that's all you have to do on that one. Okay, so hopefully you got most of those correct. We're going to look at our challenge question for today. Is the following statement true or false? So y'all read through it and try and figure out, and then unpause the video and I'll go over it. Given that we have two lines are perpendicular to each other, there exists a third line in space that is perpendicular to both of the first two lines. It wants us to provide examples. So we have a third line, and it's in our space. So it's not on a plane, it's just in this area. If I drew a line here, it is possible that it is going to be perpendicular to these other two lines. The best place to look in the classroom to see this is over in a corner. If you look at the corner, you've got two walls and either the ceiling or the floor, and the two walls have to be perpendicular to each other, and the ceiling is also perpendicular to the two walls. And if you look at just where the two walls intersect, there's a line there, and then where the wall intersects the ceiling, there's a line on each of those. And all three of those lines are perpendicular to each other, and so this statement is true because we have two lines that are perpendicular to each other. There is a third line in space that can be perpendicular to both of the first two. So that's the best example that I can think of for you to see in the classroom. Okay, so your homework tonight is 1 through 30, so make sure that y'all do those so that we can go over your questions tomorrow.